It's very cold in here. Do we have a heat pad?
Yes, here it is.
Heat pad? How does it work?
Let's ask YouTube.
Of things we know.
Welcome, curious scientists. I am Janine. Today we'll be looking at how heat packs work. But what is heat pack, you might ask? As the name suggests, it is a kind of a pack which provides heat when the liquid inside the pack is crystallized. Generally, people use it to relieve pain, but most importantly, to stay warm in winter, in cold countries like Japan. You can reuse the pack multiple times by just heating the pack back up. That's enough background knowledge. Let's get to the science part of it. And for that, we have my friend, Mani.
Before we do that, let's watch this experiment. I just seen is sodium acetate crystallizing almost instantly. It is turning from supersaturated state to saturated state. And here I have my friends Khadija, Kawai and Elijah to explain what that means.
First, we will need to understand what is saturated and unsaturated. Saturated solution refers to a solution which contains a solute, which is completely dissolved, but no more solute can be added into the solution. If more solute is added, the excess solute won't dissolve and just remain as a precipitate at the bottom of the flask.
Okay, unsaturated solution refers to a solution which contains a solute which is completely dissolved, but more solute can be added into the solution and it will still dissolve.
Supersaturated solution is a solution holding more solute than it can actually dissolve. To make a solvent dissolve more solute than it can actually hold, we have to heat the solvent.
For example, in this experiment, we heated the saturated sodium acetate solution. When we heat the solution, the molecules in the water further apart. Since there is more space, the solution becomes unsaturated. Thus, more solvent can dissolve.
Added to that, when heated oxygen and carbon dioxide in water escapes, this opens up more space to dissolve a solvent. And as there are fewer water molecules interacting with other substances in the water, more water molecules are free to dissolve the solvent. Cool fact: hot water tastes bland because of the gases escaping the water when heated.
Then we cool the solution back down to room temperature. It remains in liquid form, but now it is supersaturated. The extra sodium acetate didn't turn back into solid form, as the solution has no nucleation point, or in other words, in simple terms, no crystal structure to start crystallizing from.
So now we have supersaturated sodium acetate and we add a crystal to it. It will crystallize readily as the particles will start to build on the crystal. This is what you have seen earlier. During crystallizing, the solution releases the heat it took to form a supersaturated solution. So this is also a good example of conservation of energy that from another video.
Now, let's look at other cool things that we can do with this solution. When we pour the solution on top of a sodium acetate crystal, it forms a tower. Isn't that cool?
We can also put our hand in it and will look like this. We don't have enough solution to do that, hence we can only show the picture.
We can also use a petri dish. As you can see, the experiment failed before we even tried to put the crystal inside. What we think is because first thing when we measure the substance, we didn't measure it accurately. We rather use instruments like measuring cylinder, which is not as accurate because it's only 1 dp. So I think next time we all should use something like a burette to measure water, and while we're measuring the weight of the sodium acetate, we should be more careful that it's exact instead of 0.007 like that. And one more problem that we think we did is that while heating it up, the instruction is to heat it up slowly. But the problem is we use Bunsen burner, and Bunsen burner is not the best thing to use to control how fast you heat it. So next time we think it's better to use hot plate. I think we should use hot plate because hot plate allows you to control the temperature easily, and then most likely you can heat it up slowly. Then the experiment will be much higher chance of being successful than none.
And we have come to an end. I hope you learned something from this experiment, and feel free to try this at home. Sodium acetate can be made with vinegar and baking soda, and there are many YouTube videos showing how to do that. Thank you for watching. We hope you learned something.
One last take.
Let's go.
No, bye.
I'm facing back to front, over my shoulder at the sun, and it's an open door, and off my line of sight once more.